at this second semester starter sheet that we did at the beginning of this year. I know that it's not 2012, but we're going to use this one anyway. First off, we start with stacks of graphs. It said types of motion and directions of acceleration. Stack number 1 tells us straight up, this thing is speeding up in a positive direction. So we have a position versus time graph where the y-intercept is 0, so the starting position, the position at time 0 is 0. And let's take a look. What's the velocity versus time graph? Well, the first set of tools we used was slopes of tangent lines. So if we draw a tangent line at time 0, the starting velocity is 0. If we draw a tangent line at a midpoint, that's a small positive slope, which would be a small positive velocity. And a little while later, we have a steeper positive slope, which would be a bigger positive velocity. If we draw that, we've got a nice straight line on the velocity versus time graph. If we did the ABCs for this one up here, this slope is getting steeper, so we'd say it's an increasing slope. It's tilted upward, so it's positive. We know the slope of any position versus time graph is velocity. So if we say an increasing positive velocity, again, that velocity versus time graph matches. If we do our ABCs for this slope is constant. The slope is tilted up, so it's positive, and the slope of any velocity versus time graph is acceleration, so we should have a constant positive acceleration down here, which would be a horizontal line here. If we just did ABCs on this, well, it's always a good idea to do slopes and tangents to figure out the y-intercept for our velocity versus time graph. Our initial slope of the tangent line at time 0 is 0. If we do ABCs, we've got a slope that's getting steeper and steeper, so it's an increasing, it's tilted down, so it's a negative slope, so an increasing negative velocity, so a bigger and bigger negative velocity, so a constant negative slope there. So we describe the slope of the velocity versus time graph as a constant negative slope or constant negative acceleration, in which case our horizontal line will be below the time axis here. For our next graph, we start with a slope of the tangent line at time 0. Our starting position is 0, but the slope of the tangent line is a big steep slope. And it's a positive slope, so we know that our initial velocity is positive. A little while later, it's still a positive slope, but smaller than before. And at the end, the slope is flat or approaches 0, so that would be approaching a velocity of 0. Using our ABCs, this would be a decreasing slope because it's becoming less steep, it's tilted up, so it's a positive slope. And velocity, a decreasing positive velocity, or a smaller and smaller positive velocity approaching a velocity of 0. If we do our ABCs for this one, we've got a constant negative slope, so that's a constant negative acceleration. So we'll have a horizontal line below the time axis here. And if we come down to this last one, we draw a tangent line at time 0, that's a big negative slope. So we start with a big negative velocity, a smaller negative slope, a smaller negative velocity, and it approaches a slope of 0. So boom. So we've got a decreasing negative slope or a decreasing negative acceleration, a smaller and smaller negative acceleration. That should be a straight line. If we do our ABCs for this, the slope is constant. It is tilted up, so it's positive, and the slope of any velocity versus time graph is the rate of acceleration. So we have a constant positive acceleration. As we move down lower on this same sheet, it says when speeding up, the acceleration is always in the same direction as the motion, but when things are slowing down, the acceleration vectors are in the opposite direction of the motion. And that wraps things up for side 1, and I'll push out another video for side 2.